Something is approaching Earth that NASA doesn't want you to know about. Deep within encrypted servers at the Jet Propulsion Laboratory, a pattern has emerged in the data streams tracking 3/ATLAS, the mysterious interstellar visitor that has captivated and terrified scientists in equal measure. While public briefings speak of routine observations and natural phenomena, internal communications tell a different story entirely. They speak of trajectories that shouldn't exist, of energy signatures that defy explanation, and of timing so precise it couldn't possibly be coincidental. The question isn't whether something catastrophic is coming. The question is whether we'll see it before it's too late. The data breach that changed everything. In the early hours of September 14th, 2025, a junior systems administrator at NASA's Goddard Space Flight Center noticed something unusual in the backup logs. File transfers that should have completed in minutes were taking hours. Compression ratios that typically save 60% of storage space were barely managing 20%. Someone had been copying massive amounts of raw telescope data, and they'd been doing it for weeks without anyone noticing. By the time security traced the activity, over 400 terabytes of observational data had been mirrored to an external server farm in Iceland. The data specifically targeted observations of 3/ATLAS taken between March and August 2025, the precise window when the object was making its closest approach to the inner solar system. The breach itself was sophisticated enough to suggest insider knowledge. Whoever orchestrated it knew exactly which data sets to target, which servers had the weakest authentication protocols, and how to disguise the traffic as routine maintenance operations. Federal investigators later determined that the intrusion began with a compromised contractor laptop. But the execution showed familiarity with NASA's internal architecture that went far beyond what any single contractor should possess. Within 72 hours of discovery, the story had leaked to 3 separate journalism organizations, each receiving anonymous packages containing selected portions of the stolen data, along with analysis documents that had never been intended for public release. What those documents revealed sent shockwaves through the scientific community. Internal NASA models showed 3/ATLAS, following a trajectory that intersected not just with Mars, as publicly announced, but with calculated approach vectors toward Earth that would position the object for potential interaction with our planet's orbital path in late 2026. The probability calculations had been run thousands of times, each iteration refining the parameters, and the results consistently showed something that contradicted every public statement NASA had made. The object wasn't simply passing through, it was maneuvering. The stolen files included spectroscopic data showing chemical signatures that changed over time in ways that natural comets simply don't exhibit. Ice sublimates predictably as solar radiation increases. Rocky surfaces heat according to well-understood thermodynamic principles, but 3/ATLAS showed temperature regulation across its surface that implied active cooling systems, or at minimum, materials with thermal properties unlike anything in our solar system's natural inventory. One particularly damning document contained email exchanges between senior mission scientists debating whether to classify certain observational data as national security information, effectively removing it from the public scientific record entirely. By the time NASA issued its official response, calling the breach a criminal act and dismissing the leaked analysis as incomplete and misleading, the damage was done. Independent researchers had already begun their own analysis of the stolen data, cross-referencing it with publicly available observations and finding disturbing consistencies. The agency's credibility took a severe hit when several respected astronomers pointed out that the leaked trajectory calculations matched their own independent findings almost perfectly. If NASA had been withholding this information, what else weren't they telling us? The mathematical impossibility of natural behavior. Dr. Elena Rodriguez spent 23 years studying orbital mechanics, first at MIT, then at the European Space Agency, before becoming one of the world's leading experts on interstellar object trajectories. When she first analyzed the publicly available data on March 2025, she assumed the irregularities in its path were measurement errors or the result of asymmetric outgassing, a common phenomenon where jets of sublimating ice create tiny course corrections in cometary orbits. But as more data accumulated, Rodriguez began to see patterns that defied every natural explanation she could construct. The object was changing velocity in directions that had no correlation with solar radiation pressure, gravitational influences from nearby planets, or any other known force that acts on bodies moving through space. She ran the numbers through simulation software designed to model billions of years of solar system evolution. The program could accurately predict the positions of planets, asteroids, and comets across vast timescales by applying the fundamental laws of physics. When she input 3/ATLAS's observed behavior, the simulation repeatedly crashed or produced nonsensical outputs. The object's movements violated conservation of momentum in subtle but measurable ways. It was as if invisible hands were reaching out at specific moments to give it gentle pushes, adjusting its course by fractions of a degree, shifts so small that casual observation might miss them entirely, but significant enough to alter where the object would be months or years down the line. The velocity changes occurred in bursts that lasted anywhere from a few hours to several days. During these periods, 3/ATLAS would accelerate or decelerate by amounts ranging from a few meters per second to nearly 100 meters per second. For a natural object, such changes require either a massive impact event or sustained outgassing powerful enough to be visible from Earth. Yet during many of these acceleration periods, telescope observations showed no increased brightness, no expanding coma of gas and dust, no visible activity whatsoever. The object appeared inert, while simultaneously defying the fundamental principle that objects in motion remain in uniform motion unless acted upon by external forces. Rodriguez published her findings in a preprint server, carefully avoiding speculation about artificial origins while presenting the mathematical evidence that something unprecedented was occurring. Within hours, her inbox filled with messages from other researchers who had been quietly noticing the same anomalies, but were hesitant to speak publicly about observations that seemed to challenge established physics. A physicist from Caltech sent her enhanced analysis showing that the timing of 3/ATLAS's velocity changes correlated with its position relative to the Sun with statistical significance that ruled out coincidence. An astronomer in Chile provided photometric data showing brightness fluctuations that preceded each acceleration event by approximately 6 to 8 hours, as if the object were preparing for maneuvers. The most disturbing finding came when Rodriguez plotted not where 3/ATLAS had been, but where it would be if it continued its pattern of course corrections. The extrapolation showed multiple possible trajectories, but they all shared one characteristic. In December 2026, during what should have been the object's exit from the solar system, several trajectory options positioned it for a close approach to Earth, far closer than any previous announcement had suggested. The precision required to execute such a maneuver from interstellar space, accounting for the gravitational influences of every planet, the pressure of solar wind, and countless other variables, was beyond anything humanity could achieve with our current technology. Either the laws of physics work differently for 3/ATLAS, or something was actively piloting it through a cosmic obstacle course with Earth as a potential waypoint, the thermal anomaly that defied physics. Heat tells stories in space. Every object from tiny asteroids to massive planets radiates energy in ways that reveal their composition, internal structure, and history. When the Spitzer Space Telescope's replacement, the infrared survey satellite, turned its sensitive instruments toward 3/ATLAS in June 2025, scientists expected to see a straightforward thermal profile. As the object approached the Sun, solar radiation should heat its surface in a predictable gradient, with the Sun-facing side much hotter than the shadowed areas. Instead, the thermal imaging revealed something that made no sense within our understanding of thermodynamics. The temperature across 3/ATLAS's surface remained remarkably uniform, varying by less than 30 degrees Celsius across its entire visible area, despite being exposed to wildly different amounts of solar radiation. The sunward side should have been hundreds of degrees hotter than the portions in shadow, yet the measurement showed an impossible consistency. Even stranger, as 3/ATLAS moved through different regions of space, passing through areas of varying solar intensity, its surface temperature remained within a narrow band that suggested active regulation. Natural objects don't do this. They heat and cool according to the Stefan Boltzmann law, radiating energy at rates determined by their temperature and surface properties. They don't maintain thermal equilibrium across their entire structure as if someone were running an environmental control system. The data got stranger when researchers examined the infrared signature over time. Most asteroids and comets show daily temperature cycles as they rotate, with surface features heating and cooling as they move in and out of sunlight. 3/ATLAS showed something different. Its thermal emission remained steady even as optical observations confirmed it was rotating with a period of roughly 8.7 hours. This meant that either the object had perfect thermal conductivity, distributing heat instantaneously across its entire mass, or something was actively managing the temperature of its surface. Perfect thermal conductivity would require materials with properties far beyond anything known to occur naturally, exotic metamaterials that would be difficult even for advanced human engineering to produce. One research team noticed something even more unsettling in the thermal data. During the periods when 3/ATLAS was making its inexplicable velocity changes, specific regions on its surface showed temperature spikes of 40 to 50 degrees. Localized hotspots that persisted for several hours, then disappeared. These thermal events occurred at different locations around the object's surface, never in the same place twice, and always coincided with course correction maneuvers. The pattern suggested directed energy emission, as if rocket thrusters or some form of propulsion system were firing from multiple points around the object's structure, using different locations for different maneuvers. Scientists attempted to explain this with natural mechanisms. Perhaps 3/ATLAS had an extremely high thermal inertia, meaning it absorbed and released heat very slowly, smoothing out temperature variations over time. But calculations showed that the required thermal properties would make the object's density and composition completely unlike any known type of asteroid or comet. Alternative theories propose that a thick insulating layer of dust surrounded the object, creating a buffer that maintained steady temperatures. Yet spectroscopic observations showed no evidence of such a dust layer, and the object's sharp, well-defined edges in visual wavelengths contradicted the fuzzy appearance that extensive dust would produce. The most troubling aspect was what the thermal data implied about energy generation. Maintaining a stable temperature while moving through space requires either extraordinary material properties or an internal energy source. If 3/ATLAS possessed some form of power generation, whether radioactive decay, chemical reactions, or something more exotic, it would explain the thermal stability. It would also mean that this object, traveling across light years of interstellar void, carried within it an active energy system that had remained operational for potentially millions of years. Natural radioactive decay couldn't sustain such consistent output over those timescales. Chemical reactions would have exhausted their reactants long ago. Whatever was keeping 3/ATLAS warm defied easy explanation, and the implications were staggering. The communication hypothesis that split the scientific community. In July 2025, a team of radio astronomers at the Parkes Observatory in Australia pointed their massive dish antenna toward 3/ATLAS on what was supposed to be a routine observation run. They were looking for radio emissions that might indicate electrical activity on the object's surface, perhaps from static discharge as dust particles interacted in its coma. What they detected instead sparked one of the most heated scientific controversies in modern astronomy. The receivers picked up a narrow band signal at 1.42 gigahertz, precisely the frequency of neutral hydrogen emission that radio astronomers often use as a universal marker because any technological civilization would recognize it. The signal pulsed in a regular pattern, 0.7 seconds on, 1.1 seconds off, repeating without variation for the entire 6-hour observation window. Natural radio sources exist throughout the cosmos. Pulsars emit regular radio pulses as they rotate. Magnetars produce bursts of radio energy during flares. But these signals have characteristics that distinguish them from artificial transmissions. They're broadband, spreading across many frequencies, or they show the red shift and dispersion effects of traveling across vast cosmic distances. The signal from 3/A TLAS was different. It was remarkably clean, confined to a narrow frequency band with minimal spread, and showed none of the scattering or distortion expected from a source embedded in the interstellar medium. Most tellingly, its strength varied in sync with 3/A TLAS's position and orientation, growing stronger when the object's long axis pointed toward Earth and fading when it rotated away. This directional dependence suggested a deliberate transmission aimed at our planet, not an omnidirectional emission or natural phenomenon. The announcement of this detection split the astronomical community into fierce camps. Skeptics immediately challenged the finding, suggesting it could be interference from satellites, ground-based transmitters, or instrumental artifacts. The Parkes team responded by releasing their full data set, showing that they'd taken extensive precautions to eliminate false positives. They'd observed at times when no satellites passed through their beam, used interference rejection algorithms that should have filtered out terrestrial signals, and verified that the detection appeared only when 3/A TLAS was in their field of view. Other observatories attempted to confirm the signal, but 3/A TLAS's faintness and the precision timing required made independent verification difficult. Some teams reported possible detections, others found nothing, and the controversy intensified. Meanwhile, a subset of researchers began analyzing the signal's structure, looking for information content beyond the simple pulse pattern. They applied every technique used in the search for extraterrestrial intelligence: mathematical transformations, prime number analysis, binary encoding schemes, even musical notation. The 0.7 and 1.1 second timing pattern yielded nothing obvious. Their ratio produced no significant mathematical constant. Converted to binary, the sequence revealed no clear structure. If this was a message, it was encrypted or encoded in ways that human analysis couldn't penetrate, or possibly it wasn't a message at all, but rather a carrier wave or beacon meant to simply announce presence rather than convey specific information. The emotional impact of the radio detection extended far beyond technical debates. For decades, humanity had been listening to the cosmos, searching for any whisper that we weren't alone. Projects like SETI had scanned thousands of stars without finding anything definitively artificial. Now, potentially, an artificial signal was coming from an object inside our own solar system, not from a distant star, but from something that had traveled here, perhaps specifically to be detected. The psychological weight of that possibility was immense. If confirmed, it would mean that not only did intelligent life exist elsewhere in the universe, but it had noticed us, targeted our solar system, and sent something to investigate. The implications for human self-understanding, for our place in the cosmic order, for our future as a species, were staggering and terrifying in equal measure. The global catastrophe scenarios that keep scientists awake. Behind closed doors, in classified briefings and academic workshops conducted under strict confidentiality agreements, scientists have been modeling potential scenarios for what could happen if 3/A TLAS proves to be not just anomalous, but actively threatening. These discussions don't focus on the Hollywood notion of alien invasion with death rays and exploding cities. Instead, they examine more subtle and perhaps more realistic catastrophic possibilities that an advanced intelligence might employ if it viewed humanity as a problem to be solved rather than a civilization to be contacted. The most frequently discussed scenario involves targeted disruption of Earth's technological infrastructure. Modern civilization depends on satellites for communication, navigation, weather forecasting, and countless other essential functions. A sophisticated actor with the demonstrated capabilities of 3/ATLAS could systematically disable or destroy these satellites, not through crude kinetic impacts, but through focused electromagnetic pulses or directed energy weapons that fry electronics while leaving the satellites physically intact. Within hours of such an attack beginning, global communications would degrade dramatically. GPS navigation would become unreliable. Weather monitoring would go dark. Financial markets, which depend on precise timing signals from satellites, would collapse into chaos. The internet, with its satellite backbone connections, would fragment into isolated regional networks. A second catastrophe scenario focuses on geomagnetic manipulation. Earth's magnetic field protects us from harmful solar radiation and cosmic rays. If 3/ATLAS possesses technology capable of generating the magnetic disturbances already observed, scaling up that capability could allow it to create artificial magnetic storms far more severe than anything the sun produces naturally. Such storms would induce powerful currents in electrical grids, burning out transformers, and potentially leaving entire continents without power for months or years. The economic and humanitarian consequences would be catastrophic, dwarfing any natural disaster in human history. Food production and distribution would collapse. Medical care would become primitive. Millions would die not from direct attack, but from the cascading failures of systems we take for granted. Perhaps most terrifying is the biological scenario. If 3/ATLAS represents technology from an advanced civilization, it might carry with it biological agents designed for terraforming or environmental modification. These wouldn't necessarily be weapons in the conventional sense, but rather engineered organisms meant to alter planetary atmospheres or ecosystems to suit the needs of their creators. Releasing such agents into Earth's biosphere could trigger cascading ecological collapses as unfamiliar organisms outcompete native species, disrupt food chains, or alter atmospheric composition in ways that make the planet less hospitable to human life. The changes might occur gradually over years or decades, making them difficult to combat or even recognize until irreversible damage had occurred. A more insidious possibility involves information warfare. An intelligence capable of crossing interstellar space would possess computational capabilities far exceeding anything humanity has developed. If 3/ATLAS or signals from it were to infiltrate Earth's computer networks, it could potentially manipulate everything from financial records to military command and control systems. The object wouldn't need to destroy humanity directly. It could simply turn our own systems against us, triggering conflicts, collapsing economies, and sowing chaos through precisely calibrated interventions in our information infrastructure. We might never even know we were under attack, attributing the resulting disasters to human error, political instability, or simple bad luck. These scenarios remain speculative, the stuff of strategic planning exercises rather than imminent threats, but they illustrate why some scientists are genuinely frightened of what 3/ATLAS might represent. The object has demonstrated capabilities that shouldn't exist, followed trajectories that defy easy explanation, and shown patterns of behavior consistent with purposeful action rather than random wandering. Whether it poses any actual threat remains unknown, but the fact that we cannot rule out catastrophic scenarios means we must consider them, prepare for them, and take seriously the possibility that December 2026 might bring challenges unlike anything humanity has faced before. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.